Hi guys, I'm back. Okay, so now we're going to be talking about mid-segments and the inequalities of triangles. Big words. All right, essential question number one, what's a mid-segment? What's a mid-segment and how is it special? How are the sides of a triangle related to the angles of a triangle? All of this stuff is super interesting, I assure you. All right, so in this we're going to be defining mid-segment. We're going to be finding the relationship between mid-segment and the triangle's sides. And we're also going to be discussing the relationship between the length of the triangle's sides and the size of its angles, or like the measure of its angles. Okay, so triangle mid-segment theorem is our first main idea. If B and D are midpoints of AC and EC, then BD is parallel to AE. BD is parallel to AE, and BD equals 1/2 AE. Oh my gosh, so many words, Miss E. What are you even talking about? I got you, boo. Calm down. All we're saying is, this is a mid-segment, right in the middle. That's why we call it a mid-segment. How do you know if it's a mid-segment? Look right here. You see the markings? If you see those markings, that means it's equal on both sides, which means it's in the middle. Okay? All right, so if you see the mid-segment, this thingy right here is half of this thingy right there. So BD is half of AE. Or if you want to be fancy and flip it, you say AE is 2 times or twice the length of BD. That's all we're saying, yo. Relax. And I even wrote it right here. BD is half of AE. Okay. Exterior angle inequality. The measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. Ooh. What is she talking about? All I'm saying is this is the exterior angle, and this measurement is going to have to be a number that's greater than either of those two. Don't forget from the last test, the last unit, if you add up angle 1 and angle 2, it's going to equal angle 3. So since that's true, angle 3 has to be greater than angle 2 by itself, and angle 3 has to be greater than angle 1 by itself. That's all it's saying. Excuse me. And remote interior angles are the interior angles that are not next to the exterior angle in question. Yes. All right, these theorems, the longest side of a triangle is opposite the largest angle of a triangle, and vice versa. The largest angle of a triangle is opposite the longest side of a triangle. Again, Miss E, why are you trying to kill us with these words, yo? I'm sorry. We have to speak. All right, so if we look here at this very confusing diagram, we can see, look inside the triangle. You see the angles? You see the angles? You see them? Right there, right there, right there. Oh my gosh. So look for the biggest number. What's the biggest number? 58 degrees, 62 degrees, or 60? 62 degrees is the largest, which means that the side across from 62 degrees, which is AC, is the longest side of the triangle. That's it. The biggest angle is going to be across from the biggest side. That's all I'm trying to tell you. So same thing, the smallest angle is across from the shortest side, or the smallest side. Boom. So BC is the smallest one, which is why I put it last, because it said we had to go greatest to smallest. And then we see that 60, which is the angle that's in the middle, size-wise. 60 is between 62 and 58. So that means the side across from it is going to be the middle side, or the medium length side. So that's why I put AB in the middle. That's all we saying. Calm down. Stop making it complicated. All right, this one, we're going to do greatest to smallest again. But this time, you can see that they give us the outside numbers. And what is the outside number for again, kids? No, it's not for angles. Shame on you for saying that. It's for sides. So the outside numbers are for the sides. So they gave us the sides. So let's see. 30 is the biggest number out of all three of these numbers. So AC is the longest side, which means angle B is the largest angle because it's across from the longest side. Cool? So they match up like opposites. And then 25 is the smallest side. So that means angle C is the smallest angle. 28 is the wait for it to go away. 28 is like the middle side, which means A is like the middle angle. And I put them in order right there. All right, let's see. Triangle inequality theorem is next. The sum of the lengths of any two sides of a triangle is greater than the length of the third side, right? So I'm not even going to look at that because that's just going to confuse y'all. You can look at it if you want to. So basically we're just saying, okay, if you take these two sides and add them together, it's going to be a number greater than 9. It has to be. Otherwise, it wouldn't make a triangle. So 7 plus 8 is 15, and 15 is greater than 9. And it works for all the sides. 8 plus 9 is greater than 7. Boom, I wrote it right there. Cool. 7 plus 9 is greater than 8 because 7 plus 9 is 16 and 16 is greater than 8. It's right there. Easy stuff. All right. Inequalities involving two triangles. So this one's just saying if you have two triangles and you have these angles. So here's angle A and angle X. So since angle A is clearly obtuse, not even that it's obtuse, but it's definitely wider than angle X, that means that these sides opposite those angles fit the same description. BC is going to be bigger than YZ, since the angles opposite them fit that, they were doing the same thing. Same thing over here, it's just the converse. So if BC is greater than YZ, then we can go backwards and assume that the angles across from them are also going to be the same. So A is going to be bigger than X. All right, now we got some examples.